Good morning, everyone, and thank you for joining me today. We're going to dive into forensic analysis of glass evidence, exploring the various methods and applications that are crucial in crime scene reconstruction. We'll cover the different types of glass, their unique characteristics, and the investigative techniques used to analyze this evidence effectively. I'm excited to share this important aspect of forensic science with you. Let's get started. Glass evidence refers to any fragments or particles of glass that are collected during forensic investigations. This type of evidence is particularly valuable because glass is commonly found at many crime scenes, like broken windows, bottles, or vehicles. Its presence can create a crucial connection between suspects, victims, and specific locations relevant to the case. By analyzing the physical and chemical properties of these glass samples, investigators can reconstruct events and establish important links that help move the investigation forward. Understanding glass evidence is essential for piecing together what happened and identifying those involved. When we talk about the types of glass you're most likely to encounter, the first that comes to mind is window glass. This is typically flat and made from soda lime glass, which is very common in both homes and commercial buildings. Next, we have bottle glass, which often comes in various colors and can have different thicknesses depending on its use, making it quite versatile. Then there's automotive glass, which is specially designed for safety. Windshields are laminated to hold together on impact, while the side and rear windows are tempered to break into small, less harmful pieces. Speaking of tempered glass, this is a type of heat-treated glass that's much stronger than regular glass and shatters into small granular chunks instead of sharp shards, reducing the risk of injury. These are the main categories you'll likely run into in everyday life. When examining glass as forensic evidence, several key characteristics help us identify and compare samples. First, thickness can vary depending on the type of glass and its manufacturer, making it a useful factor for comparison. Next, color provides clues about the source or the methods used to process the glass. Density is another important property. It helps differentiate glass based on its material composition. The refractive index is particularly valuable because it measures how light bends as it passes through the glass, which is often unique to each sample. Finally, surface features like treatments, coatings, or imperfections can offer additional clues that assist in identification and linking a fragment to a specific source. These characteristics together form a comprehensive profile for forensic analysis. When analyzing glass in forensic investigations, several methods come into play. First, refractive index measurement helps us understand how light passes through the glass, which can be a unique characteristic for identification. Then, density comparison is used to evaluate the mass-to-volume ratio against known standards, giving us another physical property to compare. Elemental and chemical analysis goes deeper, revealing the glass composition at a microscopic level, which can be crucial for distinguishing between samples. Fracture matching is more hands-on. It involves physically aligning broken edges to see if they fit together, providing direct evidence of a match. Trace evidence analysis focuses on detecting tiny glass particles on clothing or objects, which can link a suspect to a crime scene. Lastly, assessing color and thickness helps classify the glass and supports comparative analysis. Each of these methods contributes vital information to build a complete forensic profile of glass evidence. When we talk about refractive index measurement, we're looking at how much light bends as it passes through a piece of glass. This bending creates a unique optical signature, which is very helpful in identifying and comparing glass fragments. One common method used is a flotation technique, where glass pieces are immersed in liquids with known refractive indices. By finding the liquid in which the glass appears to disappear or match, we can determine its refractive index quite accurately. Moving on to density analysis, this involves measuring the mass of the glass relative to its volume. Since different types of glass have varying compositions and manufacturing processes, their densities can differ, which gives us another way to classify them. The real power comes when we combine refractive index and density measurements. Together, they significantly improve our ability to accurately match glass fragments back to their sources. When examining glass composition, advanced instrumentation plays a crucial role in providing detailed insights. One key technique is scanning electron microscopy combined with energy dispersive spectroscopy, or SEMEDS. This method allows us to identify the elemental makeup of glass at a microscopic scale, giving us precise information about its composition. Another important technique is X-ray fluorescence or XRF analysis, which detects and quantifies elements without damaging the sample. Together, these techniques help reveal unique chemical signatures in glass, enabling us to differentiate sources and establish important connections between evidence and crime scenes. Fracture matching is all about physically fitting broken pieces of glass back together to see if they came from the same source or event. This technique gives us direct visual proof that can link a suspect's item to a particular crime scene. On the other hand, trace evidence analysis looks for tiny glass particles that might have been transferred onto suspects, victims, or their belongings. Even when these fragments are microscopic, they can connect individuals to specific places or incidents, making this approach incredibly important in investigations. Here we have some real-world examples that show how glass evidence can be crucial in solving cases. In one burglary case, investigators were able to connect a suspect to a break-in by matching a unique fracture pattern in a broken window. This pattern was like a fingerprint, making the link very strong. In a hit-and-run investigation, small glass fragments found at the scene were analyzed not just visually, but also for their refractive index and elemental composition. This detailed analysis matched the glass to the suspect's car, helping to confirm their involvement. Lastly, in an assault case, shards of glass found on the suspect's clothing were examined and matched precisely, both chemically and physically, to broken glass at the scene where the assault took place. These examples highlight how powerful glass evidence can be in establishing connections and supporting investigations. Glass evidence is incredibly durable and commonly found at crime scenes, which makes it a reliable source of forensic information. Because glass is often involved in break-ins, assaults, and vehicle-related crimes, it becomes a crucial piece of the investigative puzzle. Forensic scientists use a variety of methods, physical, optical, and chemical analyses, to examine glass fragments, allowing them to confidently link pieces back to their origins. This capability makes glass evidence an essential tool in reconstructing events and establishing connections that can be pivotal in solving cases. Here, we have a selection of valuable references and further reading materials to deepen your understanding of forensic glass analysis. First, forensic science textbooks offer foundational knowledge on trace evidence and material analysis, which is essential for grasping the basics. Next, peer-reviewed journal articles present the latest advancements in glass characterization techniques, helping you stay updated with current research. Additionally, online forensic resources and specialized databases provide accessible information focused specifically on material evidence. Together, these sources form a comprehensive base for both theoretical knowledge and practical application in forensic investigations involving glass evidence.